Hi, welcome to week 3 that we are going to be on chapter 4, which is about repetition structure. And basically what that means is, if you look at the bottom of page 169, the top of page 170, it's got some code in there. As you can see, there's a lot of code that's repeated. And that's one of the things we never want to do in programming, is repeat the same line. And the reason is that particular piece of code or that variable could change, and if we have that particular statement in 5 or 6 different spots, well, if I made a change to, let's say, 5 of those, and that 6th one I forgot, that's going to cause an issue. So instead of duplicating lines, we always want to do what's called repetition or looping. And one of the very first things we can utilize there on page 170 is what's called a while loop. Now, while loop says, I'm going to do this while this statement is true. While this statement is true, I'm going to do this. Let's just go ahead and open up the program to see what a while loop looks like. And let's open up commission. So come over here and click open. And again, if you're following along, you can pause this to make sure that you can get it up, and then follow along with the way I'm doing. Okay, so here's commission. I've got a variable called keep going, and I've set it to a lowercase y. And I said while keep going is equal. Remember, we got the 2 equal signs. That is a comparison. And while keep going is equal y, and that statement is true, is going to come in. Now realize everything that's tabbed in is within the while loop. If I were to take this last statement and go like that, that's outside of the loop. So remember, with Python, tabbing is how we keep things grouped together. So while that's true, I'm going to ask for the user to enter amount of sales. I'm going to convert it to a float and put it into the variable sales. I'm going to ask them for the commission rate. I'm going to convert that to a float and put it into the variable com rate. Then I'm going to say commission is equal to sales times com rate. Then I'm going to use a printf statement to say the commission is commission. I'm going to use the thousands comma separator, and I'm going to round it to 2 decimal places. And then I've got keep going is equal to, do you want to calculate another commission? Enter y for yes. So you're going to type a y to continue that loop. So if you type on a y, it's going to come right back up to this loop and keep doing these lines over and over and over again, and until you type something that's not a y. Okay, so let's go ahead and run it. This is enter amount of sales, and in the book they've got 10,000, and the com rate is 0.1, so 10%, and so the commission rate is 1,000. Then we're going to type in a y, a lowercase y, and we're going to type in 20,000, and the com rate is 0.13, I'm sorry, 0.15, and that's basically $100. Oh, I typed in 0.05. And the last one is 12,000, and the com rate is 0.10 or 0.1, which is 10%. And what just happened? That was strange. Let's try it again. So 10,000 and 0.1, 20,000 and 0.15. What keeps happening there? Wow. Am I hitting the wrong key? Let me pause for a sec. Apparently I wasn't reading. You probably caught this. I forgot to put a y right here, so y. And then 20.15. I'm going to do another one, yes. Amount of sales is 12. Commission rate is 0.1. I want to do it, I'm going to type in an N for no, and the program ends. Okay. So, as you can see, while the variable keep going was equal to a y, it kept doing what was inside of this loop. It kept going, kept going. So that's a basic while loop. And again, top page 178, this is known as a pre-test loop, meaning that if I were to do this, and I put an N for keep going, and I ran this, it's not going to do anything. Why? Because keep going was not equal y, because it's a pre-test loop. It's going to test to see, is that statement true or false? If it's false, it's time to go into the loop. So that's what they know and as a pre-test loop. So here we've got temperature. Let's open up temperature. On page 176. Now this one, he says that what we want to do is we've got a max temperature of 102.5. So there is our variable max temp. We're going to ask the user to enter a temp. And so this is kind of a makeshift, kind of a mock if we were in a real laboratory. We're trying to get the temperature down below 102.5. So we ask the user input into the substance Celsius temperature. And it says while that temperature is greater than the max temp, so if it's greater than 102.5, we're going to print the temperature is too high, turn the thermostat down and wait 5 minutes, then take the temperature again and enter it. Then we'll ask the user to enter that number again we convert to a float, and then it pops back around and it checks to see if the temperature is greater than the max temp. Once it's less than the max temp, notice it comes out of the loop and it says print the temperature is acceptable, check again in 15 minutes. So let's run it, and we're going to go ahead and type in 150. The temperature is too high, turn the thermostat down, wait 5 minutes, check temperature again. So we turn it down, we wait 5 minutes, and now it's 110. And it says it's still too high, turn it down, wait 5 minutes, check it again. Now it's 101. And it says, the temperature is acceptable, check it again in 15 minutes. So we basically were able to get that. So, now let's take a look on page 177. It's called infinite. So let's take a look at that. And this is basically a loop that we never ever want to get to, and it's called an infinite loop. And so here we've got keep going equals y, and I've got while keep going is equal to y. Now the one thing I want you to pay attention to, at no point from anywhere inside of this loop do we ever change keep going. So guess what's going to happen? This thing's going to keep going. You keep going, it's going to be just like the Energizer Bunny. It's going to keep going and going and going and going, and it will never ever stop. So these are the types of loops. We always have to make sure that when we have something like keep going, that variable had a chance to change at some point, or we're going to do what we do in this loop. Again, if you run it, it's going to keep asking for the amount of sales, the commission rate, the amount of sales, the commission rate, amount of sales, commission rate. And so they're going to keep going and keep going and keep going. So the only way to kill this is to click the stop button. So again, they kind of throw that in to let you know, hey, there is a chance sometimes where a loop will basically get a point where it never ever stops. Okay, so on page 178, we've got a thing called a for loop. And a for loop is just like a while loop where it is a pre-test. It's going to see, does that test, is it true or false, and it's going to go into it. So let's look at simple loop 1. And here I've got print. I will display the numbers 1 through 5. So it says for num in 1, 2, 3, 4, 5. So here's what it's going to do. The first time through the loop, it's going to grab the very first number in this array and throw it into the variable num. Then it prints num. The next time through, it's going to grab the next number, which is 2. It's going to throw it into num, and it's going to print that number. Then it's going to grab 3, put it in the num, 4, put it in the num, 5, put it in the num. So very simple. If I run it, I will print the numbers 1 through 5, 1, 2, 3, 4, 5. Simple as that. That's a very simple for loop. So let's open up simple loop 2. And this, just like the other one, it's going to display all the odd numbers from 1 to 9. So obviously it's going to print 1, comma 3, comma 5, comma 7, comma 9. So again, it's going to grab this array of numbers. It's going to grab each number, throw it into the variable num, print it, grab the next number, throw it in there. So when it runs, I will display the number, odd numbers 1 through 9, 1, comma 3, or 1, 3, 5, 7, 9. Okay, so we've seen numbers. Now let's take a look at some text. And so let's go ahead and open up simple loop 3. And here I've got 4 name in winking, blinking, and nod. So those, again, separated by a comma. So it's an array of text. And so it's going to grab winking, throw it into name, print it, blinking, throw it into name, print it, and nod, throw it into name, and then print it. So obviously we're going to winking, blinking, and nod on 3 separate lines. So we can do numbers, we can do text. Now let's take a look at simple loop 4. And now we're going to see something a little different. And now 4 says 4x in range 5. What the heck does that mean? Well, what that means is it's going to basically always start with 0. So the default start number for a range is 0. And it's basically going to do it 5 times. Now, what that means is it's going to start with the number. It's never ever going to end on 5. Okay? So just know it's always going to end the number before 5. So in this case, it starts at 0, and then it's going to print 1, then it's going to print 2, then 3, then 4. Now, in this case, we're not printing the numbers, we're actually printing the phrase hello world. So the very first time it's going to be 0, x will be 0. The next time through x will be 1. The next time through x will be 2, then 3, then 4. We never do anything with x, but we do basically print hello world. So if we run it, there it is, hello world printed 5 times. Now what if we did comma x? What would happen? Comma x. Now what would happen? So there it is, hello world 0, 1, 2, 3, and 4. So range basically says I will print a range of numbers, and my default is to start at 0, and I will go to the number that's in there, but I will go up to it, but not actually include that number in there. So let's take a look at squares. And this will kind of give us a little more detail on how to use the range. So we open up squares. So here I print number /t, that's a tab, so it's going to /t and then put squares. And then it's going to have 4 number in range 1, 11. So now, notice I got 2 numbers in there now. So when I have 2 numbers, it says this will be my starting number, and this will be my ending number. Now remember, it's not going to include 11. It's going to go up to 11. So in this case here, it's going to go from 1 to 10. So the first time through number is a 1. So 1 times, so we got asterisk, asterisk 2. So that's an exponent of 2. So it's basically multiplying by itself. So 1 times 1, we're going to put that in the square. And we're going to use a printf. And we're going to print the number, and then /t, we're going to print the square. And since they're numbers, they should be right aligned. So Next time through, number will be a 2. 2 times 2 is 4. We'll see this. So we'll see the number and then its square. So let's run it. And there we see. So there's number and square. That's our column heading. And so there it is. There's 1, 1, 2, 4, 3, 9, 4, 16. And we can see the square of each of the numbers between 1 and 10. So range, we can tell what number to start with, and then what number to go up to. Never includes that number. So, now let's utilize this a little differently, and let's open up Speed Converter. And let's see. Speed Converter. Okay. So here we're going to convert kilometers per hour to miles per hour. So we're going to have our starting speed at 60. That's 60 kilometers per hour. Our ending speed is 131. So that means 100 up to 131. Okay, because we're going to have our ending speed over here. And then we've got increment 10. Well, that's new. And our conversion factor is 0.6214. So first I'm going to do is I'm going to print kph/t mph. So there's our tab. We're going to kph tab mph. And we're going to have our dotted line as our underscore underneath our column headings. Now notice here inside of my for loop, inside of my range, I've got start speed, comma, end speed, comma, increment. So if we just have two numbers, the first one is the starting number, the second one is the ending number. This time we have a third number. So the first number will be the starting number, the second number will be the number we'll go up to end with, and the last one is the increment. That means how many, so each time we go through this, we're going to add this increment to the kph variable. So first time through is a 60. Okay? And so then we say mph is equal to kph times the conversion factor, and then we print, use a printf, and we're going to basically round the mph to the nearest one decimal place. And then the next time through, we're going to add 10. That's our increment. We're going to add 10 to the kph. So we're going to add 10 to 60, so it's now 70. We come in, we're going to basically take mph equals 70 times the conversion factor. The next time through is 80, 90, all the way up to 130, because we're not going to do 131. We're going to do right up to 131, which is 130. So when we run this, and there we see kph, we started at 60, we went to 70 because it's incrementing by 10, 60, 70, 80, 90, all the way up to 130, and then we can see the miles per hour conversion of kilometers per hour. So we can use range. We have a starting position, we have an ending number, and again remember it's going to go up to that number and not include that number, and then we have our increment. How much do you want to increment by? So now let's say we want to let the user, let's go back to the squares, let's let the user determine what the starting number is and what the ending number is, or at least what the starting number is. So let's grab user squares 1. And this is just like our squares. This time we're going to say this program displays a list of numbers starting at one of their squares. And so we're going to ask, how high should you go? So we're not asking for a starting position in this one. That's the next one. We're asking, how high do you want to go up to? It's going to start at 1. Where do you want to go from there? So again, we got our number in squares, and we've got our end is equal to input. How high should I go? We convert it to an integer, and we put it into end. And now here we're going to say for number in range 1, end plus 1. Notice we're doing a plus 1 because if I typed in, let's say 100 here, I would basically go up to 101. So n plus 1, so that will include the number that we typed in. And again, we're going to square that number, throw it in the square, and then print it. So if I run it, let's say I want to go up to 12. So there's 1 all the way up through 12. 12 times 12 is 144. So that's kind of neat. Now let's let the user decide where you want to start and where you want to end. So let's open up user squares 2. And here we're asking this, so again, it shows the displays the numbers under squares. We got start. We're going to enter a starting number, convert it to an int, throw it into start. End is equal input. How high should I go? We've seen this in the last one. Convert it to an int, put it into end. And then we're going to print a blank line and then print number and square and then the dashed line. So no changes there, except this time in the range I've got for number equal range start to end plus 1. We know why we do plus 1. And we square each number, so now we have a starting place and an ending place. So let's run it. Let's enter a starting number. We'll say 5, and we'll go to 15. And notice, there it is. We start at 5, and we go to 15. Okay. Now, on page 188, I'm going to go back over to a simple loop 3. I'll just go here. Okay, so what if I wanted to count backwards? Is that possible? Well, it sure is. What I could do is this. I could say I want to start at 10, and I want to end up at 0. Now again, remember, it's not going to go all the way to 0. It's going to go to the number before 0 in this case. I want to do comma, -1. So I'm going to start at 10, and I want to end at 0, and I'm going to increment with a -1. I'm going to print X right here. That's what I'm going to do. So when I run it, boom, there it is. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Notice it didn't include 0. It went up to 0, but no, it didn't include 0. I could do it by 2s. Maybe I wanted to count down by 2s. I could do that. And there's 10, 8, 6, 4, 2. Okay, so range within a for loop, really powerful, allows us to, again, there's a lot of automation there. If you don't put a starting position, it starts at 0. But if you put in a starting position, you also have an incrementer. You can increment by 1, but it defaults to 1. Or you can do it by 2s, by 10s, by hundreds, whatever the case may be. Okay, page 189, we get into what's called calculate a running total. And this is where, as we're looping, we might want to keep adding a specific number to a total, and then at the very end, we can display that total. So let's look at some numbers. And so here we have our constant called max. We set it to 5. We'll create a total, and now whenever we do an incrementer, whenever we have an incrementer, we want to basically have some kind of a totaling process, we have to initialize that incrementer. In this case, we're going to initialize it to 0, and we do 0.0, so automatically defaults to a float data type. So I'm going to say this program calculates the sum of, and then we've got end. Remember, if you end with the 2 single pick side by side, that says when I do my next print, it's going it will basically put it right up to that. Okay, and then I've got print. I'm using a print F, and I'm going to print the word max, or I'm going to print the variable max, which is 5. So it's going to say the sum of 5 numbers you will enter. Now we've got my counter, a for loop with using a variable counter in the range max. So we don't have a starting place. We don't have so basically we're going to do this 5 times. 0, 1, 2, 3, 4. And we're going to say number is equal to input, enter a number, and we convert that to an int. We throw it into the variable number. And then I say total equals total plus number. So now this is kind of strange. I'm saying total is equal to itself, plus I'm going to add something to it. In this case, I'm adding the number. And then I'm going to basically, once that, so it's going to print, it's not going to print anything. It's just going to keep adding whatever I type in to that total. And at the very end, we're going to say the total is, and then print the total itself. Okay, so let's go ahead and run it. And we'll enter in 10 and 20 and 30 and 10 and 20, and the total is 90. So basically typed in and added 10 and 20 and 30 and then 10 and 20. So is that 30 and, let's see, 60 and 30, yep, that's 90. Okay, so what you do at this point is a little class lab. Let's go ahead and pause the video and go to page 213 and do assignment number 1 called Bug Collector. Work on that and then come back and unpause this video. Okay, so hopefully you had fun with that exercise. Now, what I want you to look at is on page 191. Now, 191 really gets into how we can add items to a variable. And so I can do multiple things. So let's say I have x equals 5. I have y equals 8. Now I could do this, and I'm then going to say z equals x plus, I'm back up. I'm going to say x equals x plus y. So what I just did there is I'm saying, okay, so right now, x is waiting to be assigned. So it's going to take what's in x right now, add y to it, and then put it back into x. Now, a shortcut to do this is I could have done this. As I could have just said x plus equal y. And that does the same exact thing. It says take y and add it to x, and then put that into x. If I wanted to subtract y from x, I can say x minus equal y. And that does the same. That takes x, subtracts y from it, and puts it back into x. I can also do multiplication. I can do x asterisk equal y, and that multiplies x and y together and puts it into x. I can do x division equal y, and that takes x, divides by y, and puts that into x. I can do exponents. I can do integer division. I can do remainder. So I could actually do this. I could actually say x% equal y. And what that's going to do is that's going to take x, divide by y, and whatever the remainder is, it's going to put back into x. So those are called augmented assignment operators. And so those are some really nice shortcuts in order to basically do addition and subtraction and that type of thing, or multiplication, by just, instead of saying x equals x plus something, I can just say x plus equal that number, and it puts it back into x. Now, on page 192, it talks about this thing called a sentinel. And all a sentinel is it's a variable that we're going to assign. Well, we've already seen somewhat of a sentinel when we have that continuation where we basically said, you know, do you want to continue to put in the y? But what this one's going to do is we're going to ask for a numeric value. But we're going to say, if you want to end this program, enter in a 0, and that's going to be our sentinel value. So the sentinel is going to basically be a value put into a variable, and when that value is there, it's going to end the program. So let's take a look at property tax. And first thing you'll notice, we create a constant called tax factor, and it's equal to 0.0065. Then we're going to say print, enter the property lot number, or enter 0 to end. There's our sentinel value, 0 there. So we got lot is equal to input lot number, we convert it to an int, throw it into lot. While lot is not equal 0. So again, it's a pre-check. If I happen to type in 0 right here, it's not going to run. Then it's going to ask for a value, the property value, converts to a float, throws in the value. Tax is equal to value times the tax factor. And then we're going to say print, so printf, property tax, with a $sign, and then the tax amount using the comma separator per thousands around the 2 decimal places. And then we're going to say enter the next lot number, or 0 to end. So we type in the lot number, and it's going to keep doing this until we enter the sentinel value of 0. So let's run it. We got lot number, we'll say is 102. The property value is going to be, let's say, 150,000. Property tax is $975. The next lot number, we'll say, is 205. And that's worth $199,000, and the property tax is $1,293. I type in a 0, and the program ends. So there's our sentinel value. Okay. Okay, go ahead and do class lab. Let's go to page 213 and do number 2, calories burned. And so work on that, and when you come back, we'll start on input validation loops on page 195. So as we're getting data from our users, we have to make sure that is the data correct. For example, are they typing in numeric data correctly? Are they typing the string data correctly? So we want to make sure that what they type in is valid. So let's open up gross pay. It takes a while. So gross pay. And so here we have hours that we get from the user. We convert it to an int. We get pay rate. We get from the user. We convert it to a float. And then we say gross pay equals hours times pay rate. And we go ahead and print the gross pay is $sign. Gross pay, we print F with a comma, thousand separator, and round to 2 decimal places. So let's say we run this, and the person that is typing this in types in 400 hours this week, and they make $20 an hour. wow, they're going to get paid $8,000 this week. So there's a mistake right there. Obviously, you cannot work for 400 hours in 1 week, as much as you probably could try, but you couldn't do it. So let's say we want to put some kind of a check in there to make sure that what they type in is valid. So let's first take a look at retail no validation on page 198. Retail no validation. And here we basically say, okay, so the markup it's a constant value of 2.5. We have what's called another variable that's set to y. And while another is equal to a lowercase y or another is equal to an uppercase y, so that way there we can make sure that whether they type a lowercase or uppercase y, it's going to continue. We're going to say wholesale is equal to float input, the wholesale item cost. We go ahead and say retail equals wholesale times the markup. And then we're going to print what the retail is. And do you want to do this again? And so let's go ahead and run it. And there we can type in $10. And we're going to do yes and 15 and 12.5. Okay, so now on the bottom of page 198 it says that Samantha has encountered a problem. So she basically says, I'm using this application and sometimes I might accidentally hit the minus sign as I'm typing in the letter. Well, I don't want it to allow negative numbers. So if I were to run this and I typed in, well, let's say I typed in -10, well, it's going to show the retail price of -25, and we don't want that. So what we're going to do instead is we're going to open a retail with validation. So now we got the markup is 2.5. We got another equal to y, and we have what's called a nested loop. This is a loop inside of a loop. So the outside loop is basically saying if another is equal to y, we're going to go into this loop. And while that is a y, we're going to keep doing that same loop. Then I've got says while wholesale is less than 0. If that's true, we're going to display error, the cost cannot be negative. And then we're going to ask for the wholesale price again. So we're going to ask the user to type in the correct wholesale cost, convert to a float, and put it back into wholesale. Now notice the indentation is key here. So this while loop, since it's tabbed in, it's inside of this while loop, and this print and wholesale is part of this while loop. While we come down here to retail, that's still part of this while loop. So the indentation is very, very key as far as what is attached to which loop in this case. So, and then it does the retail wholesale times markup, and then it prints it just like it did in the other one. So the only difference is this while loop right here. So now if I run this and I type in -10, it comes up, says error, the cost cannot be negative. Enter the correct wholesale. Oh, so I type in 10, there's 25. I'm going to type no, I don't want to do any more. So validation. So I kind of say this tongue in cheek that as programmers, we have to basically deal with users, and users are the stupidest people on the face of the earth. And what I mean by that is, when we expect them to type in numeric values, they'll type in non-numeric values. When we want a certain value, they'll basically type in something else. So as programmers, we have to program around this, and this is one of those situations where we have to do that. We have to make sure that everything they type in is a positive number. Now, we also might have a max number, so we could actually do something like, while wholesale is less than 0 or greater than 200, okay? And so now we basically say, okay, if it's less than 0 or greater than 200, we're going to say some kind of an error, and then have them type in that number again. So if I were to run this again and type in think I have to say was, anyways, I'd have to go back and look. Have to do an OR here. Why doesn't that work? Yeah, I'll look that up later. But anyways, so we want to have that type of a check as well. Okay, so go ahead and pause the video, and let's do another class lab. We go to page 214 and do number 6, which is convert Celsius to Fahrenheit. When you get done with that, go ahead and unpause this video and come back. Okay, so on page 200, we get into what's called nested loops, and we just kind of covered that a second ago. We had a loop inside of a loop. Yeah, but what we want to talk about is actually having a loop inside of another loop. So let's take a look at test score averages, and let's talk about it. So, test score averages. Now, here's what we got. We're going to ask the user for the number of students there are. They're going to ask how many tests there are. And so what we're going to then do is we're going to loop through the student. And as we loop through the student, we're going to loop through all the different tests to get an average score per student. So the very first thing we do is we ask the user to for how many students there are. We convert it to an int, throw it into num students. Then we ask how many tests per student there are. We convert that to an int, and we throw it into num test scores. Then we got our for loop. We say for student equal range num students. So notice that we didn't have a starting point or an ending. We didn't have a starting point or an incrementer. So it's going to start at 0 and go up to whatever we typed in for number of students. So we typed in a 5, it's going to go from 0 to 4. We're going to print we're going to do an f print, student number, student plus 1. Again, if we got 5 students, the first student we want that to be 1, then 2, then 3, then 4, then 5, not 0 through 4. Then we're going to print a dashed line, and then we're going to have another loop. And now we're going to loop through all of the different tests. So we're going to have the user type in. So this says for test num in range num test scores. Again, we're going to basically start at 0 and go up to the number of test scores we entered per student. And again, we're going to then put test number, test num plus 1, because again, we want to start at 1. So if we got 3 tests, we want to display test 1, test 2, test 3. And then notice we've got an end here because we do not want any spacing after we basically do this test num. And then we're going to score equal float, and we're going to input a colon and convert it to a float. So we're going to have them, so it says test number and then colon. So it's going to basically print it right up against this guy, because the end says whatever you type next, butt it up against this guy. And we're going to have colon space. And then whatever they type in, we're going to convert to a float, throw it into score. Then this is where we use our accumulator, where we say total, because notice up here I have total equals 0.0. It's an accumulator, so we're going to basically initialize it to 0. And notice that we do it for each student. We're going to initialize to 0 for each student. So I go ahead and say total equals plus equals score, so we're going to add score to total. We're going to come back through again, do this for the next test, next test, next test, and then when we're done with that loop, total will show the total score that the students have. Then we're going to say average is equal to total divided by num test scores. So again, the typical average calculation. And then we're going to display, scroll down, then we're going to display the average for that student. Again, we don't want to say 0, we're going to say student 1 is average, and we're going to round to the nearest 1 decimal place. So if we run this, I'm going to say I have 3 students, and there's 4 tests per student. So for student number 1, test number 1, we're going to say they got a 98. I'm just going to throw some numbers in there. Okay, there's test 4, right? When I hit it, it basically says the average for that student was 88 for student 1. Now here's student 2. So we type in different scores. And that's their average. Now here's student number 3. And their average was that, and then it ends. So you see, we went through each student, so we're looping through each student, and with each student, we're looping for each test. Now, let's show some more looping inside of loops, and these are kind of cool. Let's open up rectangular pattern. And what this is going to do, it's going to ask how many rows do you want, how many columns do you want. And then we're going to say for R stands for rows, in range rows. So again, we're going to start at 0 and go up to the number of rows we typed in. And then inside of that, we're going to say for C in range calls, and we're going to print an asterisk, and then N says the next time you print, butt up against this one. Put no space between it. And then once it prints that asterisk, how many times of the columns there are, then it's going to do a print, which is just a new line, and then it's going to do the whole thing over again, and it's going to increase the rows. Okay? So, row 1, it's going to print all the columns, print a new line, and then come back and then print all the columns, print a blank, go to a new line, and it's going to keep doing that. So if I run this and say how many rows, we're going to say 4 rows and 6 columns. Look at that. So there's 4 rows and 6 columns each of asterisks. So pretty cool. So now let's do this. Let's open up triangular pattern. And let's take a look and see what this one does. So now we've got base size 8. So for R in range, base size. So it's going to basically go from 0 to 8. Then for C, we're going to do C in range R plus 1. Okay, so let's see how that's going to work. So the first time through, R is a 0. So I've got R plus 1, or 0 plus 1 is a 1. So it says print asterisk, and N means butt right up against it. Well, basically that's it. So it prints that 1 asterisk, and then we print a new line, and it comes back around. Now R is a 2, and so this is going to do, it's going to be a 1, because it went from 0 to 1. So now it is a 1. Now we're going to do it range 1 plus 1, 2. So it's going to basically print 2 asterisks and print a new line. Now R is a 2, and 2 plus 1 is a 3, so it's going to do this 3 times. So as you can see, we're making a triangular pattern. So let's run it to see what it does. And sure enough, there it prints. There's the 1, there's the 2 asterisks, 3, 4, 5, all the way up to 8. Now the reason it's printing 8 is because, remember R, it's going to go up to 8. But since we're doing R plus 1, it basically did 8. So there's our 1, 2, 3, 4, 5, 6, 7, 8. 8 rows. Okay. This last one's kind of cool as well. It's like this one, except it's called the stair step pattern. And now we got num steps equals 6. We've got R in range num steps, just like the other one. And this time I'm saying for C in range R. So what this is going to do is it's going to print a space and then an end, and then once it's done with that loop, it's going to print a hashtag and come back and do it again. So look at this first one, 4C in range R. So first time through, R is a 0. So it's not even going to print anything. So it's not even going to go into this loop. And then it prints a hashtag. It comes back. Now R is a 1. Now it says 4C in range 1. So it's going to print a space. It ends that loop. And then it's going to print a hashtag. So when we get done, this is what it looks like. Stair steps down. There's a bunch of spaces in front of these guys because of the range, the nested loop inside of a nested loop. Okay, 207 gets into turtle graphics. You're more than welcome to go through that on your own. They're always kind of fun. Like there's one, they're going to draw a stop sign. Again, make sure you, from the last one, you do the T equals turtle dot, capital T turtle, left and right parentheses, and do the import first, and then you'll have to use the T as your turtle. So again, you're more than welcome to try these. I think there is a concentric circles. Yeah, there's concentric circles. So you can open up that and then basically load it into the turtle program and then basically play around with that way. Yeah, and there's a spiral circles. Yeah, that's pretty cool. Okay, so again, if you have any questions, by all means, you can email me. We can set up a Zoom meeting, however you need to. But basically, this is it for Chapter 3. See you next week on when we get to chapter. I'm sorry, that was Chapter 4. We're going to be Chapter 5 next week. So, see you next time.